There is an insect alive today that could not exist without your ancestors putting on clothes for the first time. It is not a metaphor. It is a measurable, breeding, evolving animal, and it is still with us. Scientists call it the human body louse. Unlike the louse that lives in your hair, this one cannot survive on bare skin. It has no grip strong enough for a naked scalp. No legs shaped for climbing through fur that no longer exists on the human body. It needs fabric. It needs seams. It needs the folds of a garment worn against the body day after day, night after night, for shelter and for warmth. And because it needs clothing to exist at all, the moment this insect first split away from its ancestor, the common head louse, marks something researchers had almost given up trying to find. The approximate moment human beings began to wear clothes. That moment is not written on any wall. It left no burial, no painted symbol, no monument. Cloth rots, hide decays, thread disappears within a few centuries in almost any climate on Earth. 100,000 years is long enough to erase almost everything a person could have worn, stitched, or wrapped around a child on a cold night. Archaeologists have spent over a century staring at this problem. They can find the bones of the people. They can find the stone blades they cut meat with. They can find the fire pits where they slept. But the actual clothing, the material that once stood between a human body and the cold air of an ice age, is almost never there. It should be one of the most basic facts of prehistoric life. And for most of the history of archaeology, it was one of the most unanswerable. Then researchers turned to an organism nobody had thought to ask. Lice are parasites, and most parasites are not useful witnesses. They come and go with their hosts, adapting quickly, leaving little trace. But the human body louse turned out to be different. It is a specialist. It lives nowhere else. It cannot survive without the specific environment that clothing creates, the narrow gap of warmth and darkness between fabric and skin. When a population of insects becomes trapped in one very specific way of living, its DNA begins to carry a record of exactly how long it has been living that way. Scientists realized that if they could measure how long ago the body louse split away, genetically, from the head louse that still lives in human hair, they would be measuring something almost nobody had been able to measure before. They would be finding the approximate date of one of the most important survival inventions our species ever made. This is the story of what that clue revealed, and what it did not. It begins earlier than clothing itself, with a stranger fact that most people never think about. Human beings did not start out needing clothes. For a very long stretch of our evolutionary history, we did not have them, and for an even longer stretch before that, we did not need them because we were still covered in hair. Something happened to change that. Our ancestors lost most of their body hair, becoming one of the very few mammals on Earth with mostly bare skin. That change came first. Clothing came much, much later. In between lay a long, physically dangerous gap, a period in which the human body had already given up its natural coat, but had not yet replaced it with anything at all. Understanding when clothing began means understanding that gap. It means understanding why a hairless, exposed body could survive in Africa for an extraordinarily long time without any covering, and what eventually forced a change. It means following the evidence into cold caves in France, hide-working sites in the Middle East, deer-ribbed tools carried by people who were not even our species, and the genetic record hidden inside an insect that most people would kill on sight without a second thought. By the end of this investigation, the picture is not simple. There is no single day when someone first wrapped an animal skin around their shoulders and changed history. But there is a window, narrower than you might expect, when the evidence from lice, from stone tools, from bone needles, and from the pattern of human migration into colder parts of the world begins to agree with itself. That agreement is rare in the study of deep prehistory. When independent lines of evidence start pointing toward the same conclusion, it usually means something real is being uncovered. Consider for a moment what it actually takes for a question like this to have any answer at all. Somewhere, tens of thousands of years ago, a person picked up a freshly removed animal hide, still heavy and stiff, and began the long, patient work of turning it into something wearable. They had no written instructions to follow. They had only what someone before them had shown, by hand, through repetition, through trial and correction across years of practice. That knowledge passed from person to person in exactly the same basic way skills still pass between people today, a parent guiding a child's hands, an older worker correcting a younger one's technique, small adjustments accumulating slowly into real expertise. Somewhere in that long, unrecorded chain of teaching and learning, clothing became a permanent, reliable part of human life. And once it did, it never left. Every piece of clothing anyone has ever worn since, however different it may look, sits at the far end of that same original chain. Before we can understand when clothing began, we have to understand why it was needed at all. And that requires going back much further than most people expect, to the moment our ancestors' bodies changed in a way that made clothing not just useful, but eventually necessary for survival outside of Africa. One quick note before we continue. If your family has any memory of handmade clothing passed down through generations, a grandmother who sewed, a grandfather who worked leather, a story about a coat that was kept and repaired for decades rather than replaced, it is worth holding on to that thought. We will return to why that memory connects to something much older than anyone in your family tree could have imagined. What comment does this bring to mind for you? If a memory like that exists somewhere in your own family, a piece of handmade clothing kept and mended rather than thrown away, a relative known for that particular kind of quiet skill, it would be worth sharing in the comments below, because that memory reaches back much further than most people realize. Chapter 1. The Body That Lost Its Coat. To understand why clothing eventually became necessary, you have to start with something that sounds backward. Long before humans wore anything, our ancestors lost the natural covering nearly every other mammal on the African savanna still had. We became bare-skinned, not partially, not in patches. Across almost the entire surface of the body, the dense hair that once protected human ancestors from sun, cold, and insects was reduced to nearly nothing, leaving skin exposed in a way that is unusual among mammals of similar size, living in similar environments. This was not a small change. Hair is not decoration. For a mammal living outdoors, a full coat of hair regulates temperature, blocks ultraviolet radiation, and provides a physical barrier against insects, thorns, and minor injury. Losing it is a serious biological gamble. It only makes sense as an evolutionary trade if something else is gained that outweighs the loss. Researchers studying this question have focused on one likely driver: heat. Early members of the human evolutionary line were becoming more active on open, sun-exposed ground, covering longer distances on foot in the heat of the day, in environments where shade was scarce and the sun was intense for much of the year. A heavy coat of hair traps heat close to the body. For an animal that needed to move, hunt, and travel long distances without overheating, that trapped heat became a liability. Human beings are unusual among primates in the sheer number of sweat glands covering the skin. Losing body hair allowed sweat to evaporate directly off bare skin, cooling the body far more efficiently than fur ever could. This is very likely a large part of why the hair was lost in the first place. It made the human body an extraordinarily efficient long-distance cooling machine, at the cost of leaving the skin itself unprotected. That cost mattered immediately. Bare skin under strong equatorial sun faces a serious problem: damage from ultraviolet radiation. Skin without protective pigment is vulnerable to burning, to cellular damage, and over a lifetime, to consequences that would have reduced survival and reproduction in ancient populations living outdoors every day of their lives. The evolutionary solution to this new vulnerability was not clothing. It was skin color itself. Geneticists studying a gene called MC1R, which plays a central role in determining pigmentation, found something striking when they examined its variation across human populations. In populations with deep ancestral roots in Africa, this gene shows almost no variation at all. That absence of variation is itself a kind of fossil. When a gene shows unusually low diversity across a wide population, it usually means that at some point in the past, one version of that gene became so strongly favored by survival pressure that it swept through the entire population, eliminating competing versions almost entirely. Researchers who modeled how long this kind of genetic sweep would take concluded that the loss of body hair and the resulting shift toward permanent, protective dark pigmentation was substantially complete more than 1 million years ago. 1 million years. Read that number again, because it matters for everything that follows. Human ancestors were walking around with exposed, darkly pigmented skin, adapted for heat regulation and sun protection, for an enormous span of time before anyone in our lineage ever wore a stitch of clothing. The hairless body came first, by a margin so large it is difficult to fully picture. If the full span of that hairless, clothing-free existence were compressed into a single day, clothing itself would not appear until the very last moments before midnight. This changes the entire shape of the question we are investigating. The mystery is not simply, when did humans start wearing clothes? It is closer to, how did a species that gave up its natural insulation more than 1 million years ago manage to survive for such an enormous stretch of time afterward with nothing to replace it, and what finally forced a change? The answer to the first half of that question is straightforward, even if it is easy to overlook. For most of that million-year stretch, our ancestors did not need clothing because they were living in warm, tropical parts of Africa, where a bare, sweat-cooled body was an advantage rather than a danger. Nights could be cool, and early morning air could carry a real chill, but nothing close to the sustained, punishing cold of higher latitudes during an ice age. A hairless body in equatorial Africa is a finely tuned survival tool. The same body, unprotected, in the depths of a European winter, tens of thousands of years later, is a body in serious danger of dying from cold within hours. That gap between environments is the real engine behind this story. As long as human populations stayed within the warm regions where their bodies had evolved, the loss of body hair was simply an advantage, full stop. The trouble began only when people started moving beyond those regions, into territory their bodies were never built to withstand unprotected. Understanding when clothing began is, in a very real sense, the story of understanding when humans first needed a replacement for the coat evolution had already taken away from them 1 million years before. It is worth sitting for a moment with just how strange this sequence actually is, because it runs against the assumption most people carry without ever examining it. A natural, comfortable assumption is that clothing and hairlessness must have arrived together as a single package, one adaptation trading neatly for the other in the same stretch of time. The genetic evidence says something far stranger. It says our ancestors spent an almost incomprehensibly long stretch of time, the vast majority of the time that has passed since the loss of body hair began, as bare-skinned, sun-adapted, sweat-cooled animals with no woven or stitched covering of any kind. Fire came into regular controlled use at some point during this same long stretch, offering warmth at night around a hearth. But fire is not portable in the way clothing is. A person can only be as warm as the reach of the flames allows, and only for as long as fuel remains available and someone tends it. A hairless body walking, hunting, or traveling any real distance away from a fire during a cool night or a cold season had no equivalent protection at all, for a period of time that dwarfs, many times over, the entire span of recorded human history that has followed. This is not a small detail to be glossed over on the way to the more exciting part of the story. It is, in some ways, the single most important piece of context for everything that follows. Every question this documentary asks from this point forward, when clothing began, why it began when it did, what forced the change, has to be understood against the backdrop of this enormous prior stretch of exposed, unclothed survival. Whatever pressure eventually did produce clothing had to be significant enough to finally break a pattern that had otherwise held steady, essentially unchanged, for the greater part of 1 million years. That need did not appear the moment early hominins first wandered into a colder valley or a higher altitude. Early relatives of modern humans, and other hominin species that came before and alongside them, moved into some cooler regions long before anatomically modern humans existed at all. But those earlier populations were different from us in important ways, and the way they dealt with cold, if they dealt with it through clothing at all, has to be examined separately from our own species' story. Before we can look at when our specific branch of the human family began wearing clothes, we have to look at what evidence exists at all for prehistoric clothing, and why that evidence is so difficult to find in the first place. That difficulty is not a minor technical footnote. It is the central problem this entire investigation exists to solve. Chapter 2: The Invisible Invention. Archaeology is a science built on what survives. Stone survives, bone survives, under the right conditions, for hundreds of thousands of years. Fire leaves charcoal that can last just as long. But the things people actually wore against their skin, the hides, the furs, the woven plant fibers, the sewn seams, belong to a category of material that almost never makes it into the archaeological record at all. Cloth and hide are organic. They are eaten by bacteria, broken down by moisture, consumed by insects, and destroyed by simple exposure to air and sunlight. Under normal conditions, a garment made from animal skin has a survival window measured in years or decades, not millennia. A single winter with heavy rain can be enough to destroy what remains of a hide left outdoors. This creates what researchers describe as a serious archaeological blind spot. It is entirely possible, and in fact likely, that people were making and wearing clothing for tens of thousands of years before any physical trace of that clothing survived to be found by a modern excavation. The absence of preserved garments in the archaeological record does not mean clothing did not exist. It means clothing, if it existed, has already been erased by the ordinary passage of time. There are rare exceptions. In extremely cold, dry, or oxygen-poor environments, organic material can occasionally survive far longer than normal, preserved by conditions that essentially halt decay. Permanently frozen ground, extremely arid caves, and waterlogged sites sealed away from oxygen have all produced isolated pieces of ancient organic material that would otherwise have vanished completely. But these conditions are the exception, not the rule, and they only exist for a small fraction of the places prehistoric humans actually lived. For the vast majority of human history, in the vast majority of locations, if a person wore something made of hide or fiber, that garment is gone now, without a trace, regardless of how old or recent it actually was. So archaeologists were left with a genuine problem. They wanted to answer a basic, important question about human history, and the one kind of evidence that would answer it directly the clothing itself, was almost never going to be available. This forced researchers to do what scientists in many fields eventually have to do when direct evidence is unavailable. They had to look for indirect evidence instead. Not the clothing itself, but the traces left behind by the process of making it. The first kind of indirect evidence came from stone tools. Certain stone tools, when examined closely under magnification, show wear patterns consistent with a very specific task: scraping the flesh and fat from the underside of an animal hide, a necessary early step in turning a fresh skin into something that can be worked, softened, and eventually worn or used as covering. These hide scrapers appear at a number of ancient sites across Eurasia, some of them extremely old, dating back to the early and middle Pleistocene, long before anatomically modern humans existed. Sites such as Schöningen in Germany, Kesem Cave in the Middle East, and Hoxne in England have all produced evidence of animal skinning and hide preparation stretching back an extraordinarily long time. This tells researchers something important, but it does not tell them everything. Hide scraping does not automatically mean clothing. Animal skins were useful for many purposes beyond wearing them, as ground coverings, as containers, as material for building shelters, as insulation for sleeping areas. A scraped hide could have been turned into a bag, a floor covering, or a wall for a shelter, just as easily as it could have been turned into something worn on the body. The presence of hide-working tools tells us people were processing animal skins. It does not by itself tell us they were wearing them. Some of these hide-working sites reach back to a genuinely startling depth of time, well before either modern humans or Neanderthals existed as distinct populations. At Schöningen, in what is now Germany, alongside a remarkable collection of wooden spears used for hunting, researchers have also recovered bone tools bearing wear patterns consistent with smoothing and working hide, associated with the broader activity of processing animals killed at the site. At Kesem Cave, in what is now Israel, similar evidence for animal skinning and hide preparation appears in layers of occupation stretching back several 100,000 years, produced by an early human population predating both later Neanderthals and modern humans in the region. These sites establish something important on their own. The basic practice of removing and preparing animal hide is not a behavior that begins with our own species, or even with Neanderthals specifically. It stretches back considerably further, into a period when multiple different, now extinct branches of the broader human evolutionary family were already handling animal hides with enough skill and consistency to leave a lasting mark on their tools. To get closer to actual clothing, researchers needed a different kind of clue. Evidence not just of processing hides, but of working them into shapes that fit a human body, joined together with some form of stitching or binding. This is where a very different category of tool becomes important. Small, carefully shaped implements made from bone rather than stone, designed for a much more delicate task than scraping. And it is where the story of clothing begins to intersect with the story of another species entirely, one that lived in Europe long before modern humans arrived there, and who may have been working animal hides into something resembling clothing long before we were. Before turning to that story, it's worth pausing on what this chapter has actually established. The record of ancient hide-working stretches back a very long way, deep into a period before our species existed. But hide-working is not clothing. It is a necessary early step, one piece of a much longer chain of activity that might, eventually, end in a finished garment. The next piece of that chain, the tools used to actually shape and join hides into fitted coverings, takes the investigation somewhere unexpected, into the hands of a different kind of human altogether. Chapter 3. The Other Humans Who Stayed Warm. For a long time, the popular image of Neanderthals was almost cartoonish, a slow-witted, brutish cousin of modern humans, poorly equipped for survival, eventually outcompeted and replaced by the smarter, more capable species that would become us. That image has been steadily dismantled by decades of careful archaeological work, and nowhere is the correction more striking than in the evidence surrounding cold weather survival. Neanderthals lived across a huge stretch of Ice Age Europe and Western Asia for a very long time, hundreds of thousands of years, through repeated cycles of glacial cold and relative warmth. Some of the environments they inhabited were brutally cold, especially during glacial maximums, with winters far more severe than almost anywhere modern humans evolved in Africa. A species without some form of protection against that cold simply could not have survived there for as long as Neanderthals clearly did. The question archaeologists began asking was not whether Neanderthals had some way of coping with cold. The evidence of their long-term presence in freezing environments made that obvious. The real question was what that coping strategy actually looked like and whether it involved anything we would recognize as clothing. The physical evidence, once again, does not include a surviving Neanderthal coat. What it does include is a growing collection of tools whose function strongly suggests hide working aimed specifically at producing soft, flexible, wearable material rather than stiff, unworked skin. Among the most important of these are objects called lice, smooth, polished tools, typically made from a rib bone, shaped and worn through repeated use into a rounded, glossy working edge. Researchers who found fragments of these tools at Neanderthal sites in southwestern France recognized the wear pattern immediately because it matches almost exactly the wear pattern produced by modern leatherworkers using similar rib bone tools today to make hides supple, water-resistant, and durable. Radiocarbon dating placed some of these tools at roughly 50,000 years old, made and used well before modern humans are known to have arrived in that part of Europe. This detail matters enormously. It means Neanderthals were not copying a technique modern humans brought with them. They developed this specific hide-softening technology independently, or at least without modern human contact, using their own understanding of bone and hide. One archaeologist involved in the discovery went so far as to suggest that this piece of Neanderthal technology might represent one of the only pieces of Neanderthal heritage that modern human society, in some indirect way, still uses today, since broadly similar bone tools remain part of traditional leatherworking practice in some cultures even now. Other Neanderthal sites have produced smaller versions of similar hide-smoothing tools, sometimes called smoothers, found in multiple locations across France, in archaeological layers directly associated with Neanderthal occupation. At one site known as Grotte du Renne, several of these tools were recovered from layers dated to a period roughly 42 to 45,000 years old. Taken together, this collection of hide-softening tools, spread across multiple sites and stretching back tens of thousands of years, paints a picture of Neanderthal populations who were not simply draping raw, stiff animal skins over themselves for basic protection. They were actively working those skins into something closer to usable, flexible material, the kind of material a person could plausibly wear without it chafing, cracking, or restricting movement. There is a second, even more striking piece of Neanderthal evidence, and it does not come from a hide-working tool at all. It comes from a small, almost accidental discovery on the underside of a stone tool recovered from a site in southeastern France. Researchers examining the tool under magnification noticed something unexpected: a small cluster of fibers, twisted together in a way that does not happen naturally. Twisting fibers together to increase their strength is not something that occurs by accident in nature. It requires deliberate action, an understanding that individual weak fibers, when spun together in a particular direction, become a single, much stronger thread. This is, in essence, the basic principle behind all cordage, all rope, and all thread, the foundational technology behind sewing, binding, and eventually weaving. The fragment itself was tiny, a small, twisted segment barely more than 0.5 millimeter wide, but its existence was enough to establish something researchers had not been able to confirm before, that Neanderthals possessed the cognitive and practical understanding required to manufacture string. The material appeared to come from the fibrous inner bark of a tree, meaning that whoever made it understood not just the mechanical principle of twisting fibers together, but also which specific plant materials in their environment were suitable for the task, and, researchers noted, likely needed some working knowledge of basic counting or pattern tracking to manage the twisting process consistently. The site itself was dated to somewhere between 40 and 50,000 years old. It is worth being clear about how researchers actually recognize this kind of specific hide-softening wear pattern on an ancient bone tool, because the process itself demonstrates how much careful, patient work goes into building confidence in a claim like this one. Researchers do not simply look at a bone fragment and guess at its function based on its general shape. They examine the tool's surface under magnification, comparing the specific pattern of polish, striation, and rounding it carries against wear patterns produced experimentally by researchers using freshly made replica tools on real animal hide, tracking exactly how a bone tool's surface changes after a known, carefully recorded number of hours spent softening a specific type of hide. When an ancient tool's wear pattern closely matches the wear pattern produced by this kind of controlled, modern experimental replication, researchers can state with real confidence, not certainty, but confidence grounded in direct physical comparison, that the ancient tool was very likely used for a similar purpose. This is precisely the kind of careful, evidence-based reasoning that separates a responsible archaeological claim from mere speculation, and it is exactly the kind of reasoning that supports the Lice identification at the Neanderthal sites in France. None of this proves Neanderthals wore fitted, tailored clothing in the way later humans eventually did. There is no surviving Neanderthal garment, and there likely never will be. But the combination of hide-softening tools, hide-scraping evidence, and now direct proof of string-making technology strongly suggests that Neanderthal populations had, at minimum, the practical toolkit necessary to produce simple, wrapped or draped hide coverings, quite possibly held together or reinforced with cordage, well before modern humans are believed to have arrived in the same territory. Some researchers have proposed that Neanderthal clothing likely took the form of relatively simple, loose garments, something closer to a wrapped hide or a poncho-style covering, rather than a closely fitted, tailored garment sewn with precision. That distinction between loose, wrapped clothing and closely fitted, sewn clothing turns out to matter a great deal for the rest of this investigation, because it marks a real technological boundary that later evidence will help us trace much more precisely. There is one more piece of Neanderthal evidence worth including here, because it changes how we should picture the actual moment of hide preparation itself, rather than simply the tools involved. Careful microscopic study of stone tools recovered from several Neanderthal sites across France has identified wear patterns consistent not just with scraping flesh from the underside of a hide, but with a further stage of processing, working a hide back and forth over a taut edge or cord to physically break down its fibers and prevent it from drying into a stiff, board-like state, a technique closely related to methods still used in some traditional hide working today. This detail matters because it shows Neanderthal hide preparation was not a single, simple step. It involved a recognizable sequence: skinning, scraping, then a distinct softening stage, each requiring its own tool and its own trained technique, carried out by people who understood that raw hide needed several rounds of deliberate intervention before it became something a body could comfortably wear. It is worth understanding, too, that Neanderthals were not relying on clothing and technology alone to survive the cold. Their bodies themselves carried real physical adaptations suited to a colder climate. Adaptations that developed over hundreds of thousands of years of Neanderthal populations living specifically in Ice Age Europe and Western Asia, quite different from the tall, comparatively slender build associated with early modern humans adapted to warmer African environments. Neanderthal skeletons generally show a stockier, more compact build, with a broader trunk and comparatively shorter limbs, a body shape that, in cold-adapted mammals generally, reduces the ratio of exposed skin surface area to overall body mass, helping to conserve internal heat more effectively than a taller, leaner frame would manage in the same conditions. Even the distinctive shape of the Neanderthal nasal region, long a subject of debate among researchers, now appears to reflect this same cold weather specialization, with an internal structure well suited to warming and moistening cold, dry air before it reaches the lungs. This principle, a more compact body shape conserving heat more efficiently in cold climates, is well documented across many cold-adapted mammal species generally, and its appearance in the Neanderthal skeleton is treated by researchers as a genuine, independently evolved parallel to that same broader biological pattern, rather than a coincidence. This matters for the overall investigation because it means Neanderthal cold survival was very likely never a matter of clothing alone. It rested on a combination of biological adaptation built up over an extremely long span of evolutionary time, and cultural, technological adaptation, fire use, shelter construction, and hide working, layered on top of that underlying biology. Modern humans, by contrast, arrived in these same cold environments, still carrying essentially the same tall, comparatively lean, heat-adapted body shape that had originally evolved for the warmth of the African savanna, a body with comparatively little built-in biological defense against genuine cold. This makes the cultural technology of clothing considerably more important and more urgently necessary for modern human survival in cold climates than it may have been for Neanderthals, who could rely on real physical adaptation to shoulder at least part of the burden that clothing alone had to carry for modern humans moving into the same territory. This is a useful point to keep in mind whenever the comparison between Neanderthal and modern human cold weather survival comes up, since it means modern humans were, in an important sense, more dependent on cultural technology alone, with less biological cushion to fall back on, than the Neanderthal populations already established in the same challenging territory long before we arrived there. For now, the important takeaway is this. Cold weather survival clothing, in some form, very likely existed among a human population that was not our species at all, tens of thousands of years before the clearest evidence for our own species' clothing appears in the places researchers have traditionally looked. That timeline creates an obvious and important question. If Neanderthals were working hides and making cordage that long ago, what about the ancestors of modern humans, who were, during roughly the same period, still living primarily in Africa? Did they develop a similar toolkit around the same time, earlier, or significantly later? Answering that question requires leaving the caves of Ice Age France behind and turning to a source of evidence nobody expected to be useful at all, a small, wingless, blood-feeding insect that most people spend their whole lives trying to avoid. Chapter 4. The insect that could not live without us. If you have ever dealt with head lice in your own family, you already know something important about these insects without realizing it. Head lice are extraordinarily specialized. They cling to hair using claws shaped precisely to grip a hair shaft of a particular thickness. They lay their eggs, called nits, glued firmly to individual strands of hair close to the warm scalp. Everything about their body is built for one very specific environment: human hair on a human head close to human body heat. Now consider a second, closely related insect, the human body louse. At first glance, under a microscope, it looks almost identical to the head louse. For a long time, scientists debated whether it was really a separate species at all, or simply the same insect living in a slightly different location on the body. But careful study revealed real, consistent differences, not just in behavior, but in basic anatomy. The claws of the body louse are shaped differently, suited not to gripping individual hair shafts, but to gripping the woven fibers of fabric. Its body proportions differ slightly as well. And most importantly, its behavior is fundamentally different. The body louse does not live on skin or in hair at all. It lives in clothing, moving onto the skin only briefly to feed, then retreating back into the seams and folds of fabric to rest, hide, and lay its eggs. This is not a minor lifestyle preference. It is an absolute requirement. Researchers who have studied body lice extensively describe them as being so specifically adapted to clothing that they cannot maintain a population without it. Take away the fabric, and the body louse population collapses. It has no fallback option, no ability to simply move back into human hair and continue as before. Evolution shaped this insect around one very particular environment, and that environment does not exist in nature. It only exists because humans invented it. This is where an obvious but powerful piece of logic comes into play. If body lice can only survive in clothing, and clothing is something humans make rather than something that occurs naturally, then body lice as a distinct population could not have existed before clothing did. There would have been nowhere for them to live. This means that whenever body lice first split away, genetically, from the ancestral head louse population and began evolving into their own distinct lineage, that moment cannot be any earlier than the point when clothing itself first appeared. The insect's evolutionary history is, in a very real sense, chained to the history of the technology that gave it somewhere to live. Once researchers understood this connection clearly, an entirely new research strategy became possible. If clothing itself leaves almost no direct trace in the archaeological record, but clothing indirectly created a new ecological niche that a specific insect then evolved to fill, then studying the insect's evolutionary history could serve as a substitute for studying the missing artifact directly. You cannot find the ancient garment, but you might be able to find, encoded in DNA, a record of roughly how long ago something like that garment first had to exist for this insect to have a home. The method scientists use to estimate this kind of timing is sometimes called a molecular clock. It works on a fairly straightforward underlying principle. As two populations of a species become genetically separated from each other, whether by geography, by behavior, or in this case by a fundamental difference in habitat, small genetic mutations begin to accumulate independently in each population over time. These mutations occur at a roughly steady, statistically predictable rate. By comparing the genetic differences between two related populations, in this case head lice and body lice, and by understanding roughly how quickly this kind of insect accumulates mutations generation after generation, researchers can estimate how long ago the two populations diverged from a shared ancestor. Before turning to what this method can and cannot deliver, it is worth understanding a little more concretely how mutation accumulation actually functions as a kind of clock in the first place. Every living organism's genetic material experiences small, essentially random copying changes each time it is passed from one generation to the next, changes that occur at a broadly predictable average rate for any given species, shaped by that species' own particular biology, generation length, and reproductive patterns. Most of these small changes have no meaningful effect on the organism at all. They simply accumulate quietly in the genetic record, generation after generation, functioning less like a message and more like a slow, steady drip of sand collecting in an hourglass. Two populations that were once a single interbreeding group, sharing one genetic pool, begin accumulating these small, largely neutral changes independently from the moment they become separated from one another, whether that separation comes from geography, from a shift in habitat, or, in the specific case of lice, from an entirely new ecological niche opening up that only one branch of the population goes on to occupy. The longer two populations remain separated, the more these small, independent changes accumulate, and the larger the measurable genetic difference between them becomes. Researchers, knowing roughly how quickly this particular species tends to accumulate this kind of change under ordinary conditions, can work backward from the measured genetic distance between two related populations today to estimate roughly how long ago they must have started accumulating those differences separately, which is to say, roughly how long ago they diverged from a single shared ancestral population. It is important to be honest about what this method can and cannot deliver. A molecular clock does not produce a single, precise year the way a written historical record might. It produces a statistical estimate, typically expressed as a range, with a most likely central value surrounded by a margin of uncertainty. The exact width of that margin depends on the quality of the genetic data available and the assumptions built into the mutation rate calculations. Different research teams, using somewhat different data and methods, will sometimes arrive at somewhat different central estimates. This does not mean the method is unreliable. It means, like most scientific measurements of deep prehistory, the answer comes with a range rather than a single fixed point, and responsible researchers report that range honestly rather than pretending to a precision the evidence cannot support. The first major attempt to apply this method specifically to the question of clothing came from a research team working at the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, in the early 2000s. Using genetic sequencing techniques available at the time, the team calculated an estimated divergence date for human body lice, arriving at a central estimate of roughly 72,000 years ago, with a fairly wide margin of uncertainty of plus or minus around 42,000 years. That is a broad range, spanning from as recent as roughly 30,000 years ago to as distant as over 100,000 years ago. It was a genuinely new kind of evidence, the first attempt to put any kind of number at all on a question that had previously been almost entirely unanswerable through direct means. But the width of the uncertainty made clear that this was a first step, not a final answer. Roughly a decade later, a different research team, based at the University of Florida, returned to the same underlying question with a significantly larger genetic dataset and refined statistical methods designed specifically to reduce the margin of error present in the earlier study. The lead researcher on this project had spent years studying lice, specifically as tools for understanding broader patterns of human evolution and migration, treating the insects less as pests and more as biological instruments, passengers that had ridden along on the human evolutionary journey and absorbed a record of that journey into their own genetics along the way. This second study arrived at a somewhat different and in some ways more striking conclusion. Rather than a central estimate around 70,000 years, the new data pointed toward a considerably older divergence, with estimates suggesting body lice may have first evolved as a distinct population somewhere between roughly 83,000 and as far back as 170,000 years ago. The widespread within this newer estimate still reflects real scientific uncertainty, but the overall shift toward an older date, using improved methods and more genetic data, suggested that the earlier estimate may have been conservative, and that the true origin of clothing might reach back considerably further into the past than the first lice study had suggested. Both studies agreed on something else, something that turns out to matter just as much as the exact date itself. When researchers examined the genetic diversity of body lice populations sampled from different parts of the modern world, they found that lice from African populations consistently showed greater genetic diversity than lice sampled from populations outside Africa. In population genetics, this pattern, greater diversity within Africa and reduced diversity outside it, is a well-established signature of a species whose original point of origin was in Africa, with more recently established populations elsewhere descending from a smaller, less diverse founding group that migrated outward. In other words, the lice themselves carry the same African origin signature that broader human genetic studies have long shown for our species as a whole. This detail matters because it means the clothing lice story is not just telling us roughly when clothing began. It is telling us, independently, where it likely began as well, in Africa, among the ancestors of all people alive today, before any large-scale movement out of the continent had taken place. Taken together, these two independent genetic studies, using different data and somewhat different methods but converging on a broadly similar picture, point toward an origin for human clothing somewhere in the range of roughly 70,000 to 170,000 years ago, most likely occurring among early anatomically modern human populations still living in Africa. That is an extraordinary span of time before any surviving physical evidence of actual clothing exists anywhere in the archaeological record. It means our ancestors were very likely wrapping animal hides or some early form of covering around their bodies tens of thousands of years before the oldest hide-working tools currently known to belong to our specific species. The insect got there first, in terms of what the evidence can tell us. The stone tools and bone needles would take much longer to catch up. Chapter 5. A head start before the cold. An estimate of when clothing began is only half the picture. The other half is understanding why that particular window of time matters, and this is where the lice evidence connects to a second major thread of prehistoric research: the timing of human migration out of Africa into colder parts of the world. Modern humans did not remain confined to Africa forever. At various points, populations began moving outward into the Middle East, into Europe, into Central Asia, and eventually into every inhabited continent on Earth. These migrations were not single, simple events. They happened in multiple waves, over an extended period, with some early attempts at expansion apparently failing or fading out, and later waves eventually succeeding in establishing permanent populations across enormously varied environments. Researchers studying the broader pattern of this expansion have identified roughly 100,000 years ago as a significant point when human populations began moving more substantially into colder, higher latitude regions, territory that would have been sharply more challenging for a hairless, heat-adapted body to survive in without some form of additional protection. This is where the timing becomes genuinely interesting. If the clothing lice evidence is roughly correct, and clothing first developed somewhere in a window centered, depending on which study's methods you weight most heavily, somewhere between roughly 70,000 and 170,000 years ago, that means clothing was very likely already an established technology before the major push into colder latitudes began in earnest. One of the researchers involved in the more recent lice study put this connection directly. The population appears to have started experimenting with clothing considerably earlier than survival strictly required. given that they were still living in relatively warm parts of Africa at the time. And that early tinkering with the technology, developed apparently without urgent necessity, turned out to be exactly what allowed later populations to survive the transition into much harsher environments when the time eventually came to make that move. This detail changes the emotional shape of the story in an important way. It would be easy to imagine clothing as a desperate, last-minute invention, something forced into existence the moment people found themselves freezing in an unfamiliar cold climate with no other option. The evidence suggests something different and, in some ways, more interesting. Clothing appears to have developed first, inside Africa, likely in response to milder pressures such as cool nights, seasonal temperature drops, or simply the practical usefulness of a hide covering for carrying, sitting, or sleeping, well before it became a matter of survival in the face of genuinely dangerous cold. By the time human populations did begin moving into regions where an unprotected, hairless body could die from exposure within hours, the basic technology and cultural knowledge needed to prevent that outcome had already existed for tens of thousands of years. People were not improvising clothing on the spot in a new, hostile environment. They were bringing an established, already practiced survival technology with them into new territory, refining and adapting it as conditions demanded, rather than inventing it from nothing under pressure. This reframes something important about how we should think about early human ingenuity. The image of prehistoric people constantly living on the edge of catastrophe, barely surviving moment to moment, is deeply embedded in popular imagination. The clothing lice evidence suggests something closer to the opposite, at least in this particular case. It suggests a population with enough stability, enough surplus attention and time to develop and refine a piece of protective technology well before it became strictly necessary for basic survival. That kind of forward-looking behavior, solving a problem before it becomes an emergency, is a meaningful marker of a species already capable of long-term thinking and cultural transmission, teaching a skill from one person to another, from one generation to the next, long enough for it to become a stable, reliable part of daily life. It suggests groups with enough food security, enough safety from predators, and enough spare time and attention beyond the immediate demands of each single day to experiment, to refine a technique, to teach it carefully to someone younger, and to keep that knowledge alive and improving across many years, long before any single winter made the difference between having that knowledge and not having it a matter of life or death. There is a further layer to this story, one that connects clothing to another major transition in early human survival, the loss of body hair itself, and the enormous gap in time between that loss and the eventual development of clothing to replace it. Recall that the genetic evidence for hairlessness and dark, protective skin pigmentation points to a transition largely completed more than 1 million years ago. It is worth restating this figure here, rather than simply referring back to it, because the sheer scale of the gap it implies is easy to lose track of once an investigation has moved through several further stages of evidence. 1 million years is roughly 40,000 human generations, using a generous estimate of generation length for early hominin populations. 40,000 generations of parents teaching children how to survive, how to find food, how to manage heat and cold using nothing but behavior and biology, passed with no clothing technology at all anywhere in that chain, before the specific innovation this documentary has been tracing finally appears in the evidence. The clothing lice evidence points to an origin for clothing somewhere in the range of 170,000 years ago at the very earliest, and quite possibly considerably more recent than that. Even using the oldest, most generous estimate for when clothing began, that still leaves a gap of the better part of 1 million years, during which human ancestors were living with bare, exposed, heat-adapted skin and no clothing at all to supplement it. For that entire span, an enormous stretch of evolutionary time almost impossible to hold in the mind all at once. Human ancestors survived using nothing but their own biology. Dark pigmentation to resist sun damage, an extraordinary density of sweat glands to manage heat, and, crucially, a geographic range largely confined to warm regions where a hairless body was an asset rather than a liability. It was only when that geographic range began to expand, when population pressure, curiosity, resource scarcity, or some combination of forces began pushing people toward the edges of the continent and eventually beyond it, that the absence of a fur coat became a genuine, life-threatening problem requiring a cultural solution rather than a biological one. It helps to picture concretely what this transition actually involved for the people living through it. A population accustomed to a warm African climate, where seasonal temperature variation might mean the difference between a comfortably warm day and a mildly cool night, began moving into territory where an entire season could bring sustained temperatures well below freezing, where open water froze solid, where the sun itself might barely rise above the horizon for weeks at a time during the depths of winter at higher latitudes. This is not a gradual, barely noticeable shift in climate. It represents one of the most extreme environmental transitions any population of that era could have experienced, comparable in its physical demands to very few other challenges early humans faced. A hairless, heat-adapted body moved suddenly into this kind of environment without any form of protective covering would face a genuine, immediate risk to survival within a matter of hours, not years or generations. There would have been no time for further biological adaptation to catch up. Whatever protection existed had to already be in place, ready and functional, the moment a group crossed into genuinely dangerous cold territory. This is exactly why the evidence pointing toward an earlier, African origin for basic clothing technology matters so much to the overall shape of this story. It means the necessary protection was not invented in a rush, under emergency conditions, in the middle of a dangerous migration, but had already been developed, tested, and taught within the group over a long prior period, ready to be carried outward the moment it was needed. Clothing, understood this way, was not simply about staying warm in an already cold place. It was the technology that unlocked entirely new geography for the human species. Without it, the population expansion that eventually carried human beings into Europe, into Central Asia, into Siberia, and eventually across the Bering Land Bridge into the Americas, would very likely have been impossible, or at minimum drastically delayed, and far more limited in scope. A hairless, heat-adapted body simply cannot survive a subarctic winter through biology alone. The invention of clothing, whenever exactly it happened within that broad window the lice evidence points toward, functionally rewrote the boundaries of where human beings could live at all. This raises an obvious next question. If clothing existed that early, tens of thousands of years before the oldest known hide-working tools currently attributed to modern humans, why does the archaeological record of actual tools associated with our species appear to lag so far behind? Part of the answer is the same problem explored earlier. Organic materials do not survive, and early tools used in the earliest stages of clothing making may themselves have been simple enough, or made from materials fragile enough that they left no lasting trace either. But part of the answer also lies in a genuine documented shift in the technology itself, a shift from simple, wrapped or draped hide coverings towards something more advanced, fitted, tailored clothing sewn together with real precision. That shift, unlike the origin of clothing overall, does leave physical evidence behind, and it is where the archaeological record and the genetic record finally begin to meet. Chapter 6. From Wrapping to Tailoring. There is an important difference between simply covering a body and actually fitting a garment to it, and archaeologists have learned to look for the specific evidence that separates these two levels of technology. A loose hide, draped over the shoulders and perhaps tied at the front, would already provide meaningful protection against wind and moderate cold. It requires only a basic hide scraper to prepare, and it requires no precise cutting, no measuring, no stitching. This is very likely close to what early clothing looked like, both in Africa before migration began, and quite possibly in the simple, poncho-style coverings researchers have proposed for Neanderthal populations working with lissoirs and hide smoothers. Fitted clothing is a different matter entirely. A garment that follows the shape of the arms, that closes tightly around the torso, that traps a thin layer of warm air directly against the skin, rather than allowing cold air to circulate freely underneath a loosely draped hide, provides dramatically better protection in genuinely severe cold. But achieving that fit requires real technical skill. The hide has to be cut into shaped pieces. Those pieces have to be joined together in a way that holds under movement and stress, without large gaps where wind and cold can penetrate. That kind of joining requires a tool capable of making a controlled, repeatable hole through tough, prepared leather, allowing a length of sinew, plant fiber cord, or other thread-like material to be threaded through and pulled tight. The earliest tool researchers associate with this more advanced tailoring is a simple but effective implement known as a bone awl, essentially a sharpened, pointed length of bone used to punch or pierce a hole through prepared hide. Awls are simpler to make than needles and do not require the difficult, delicate work of drilling a small-eyed opening through solid bone or ivory. Archaeological evidence indicates that bone awls capable of this kind of piercing work were in use by roughly 80,000 years ago. This date lines up remarkably well with the older end of the clothing lice estimates, and it strongly suggests that by this point, human populations, still largely within Africa, were moving beyond simple draped coverings and beginning to produce clothing shaped and joined with enough precision to qualify as genuinely tailored or fitted garments, even if the stitching method remained relatively basic. A more advanced tool appears considerably later in the archaeological record: the eyed needle, a slender implement made from bone, antler, or ivory, featuring a small drilled or carved hole near one end through which thread can be permanently fed, allowing for continuous, controlled sewing in a way a simple awl cannot match. Eyed needles require significantly more skill and time to manufacture than awls. Drilling or carving a clean, functional eye through solid bone or ivory without cracking the material or leaving an opening too weak to hold thread under tension is a genuinely difficult craft task, one that implies real specialization and practiced skill passed down through careful teaching. Producing a working-eyed needle was, by the standards of prehistoric technology, a genuinely demanding craft process, worth understanding in some practical detail because it helps explain why this specific tool appears so much later than the simpler bone awl. A suitable piece of bone or ivory first had to be selected and split, or carved down into a long, narrow, roughly needle-shaped blank, thin enough to pass through prepared hide without tearing it, yet strong enough not to snap under the repeated pressure of sewing. The surface then had to be carefully smoothed and shaped along its entire length, removing any rough or uneven sections that might catch or damage the material being sewn. The most difficult step came last, creating the eye itself, a small hole near one end of the needle, typically produced by patiently working a sharp stone point back and forth to gradually bore through the material from both sides until the two openings met in the middle. This had to be done with real precision. Too large an opening, positioned too close to the needle's edge, and the surrounding bone would crack or snap the first time real tension was applied while sewing. Too small an opening, and no thread could be reliably passed through it at all, producing a single reliable, durable-eyed needle. By most reasonable estimates based on experimental reconstructions researchers have carried out using comparable tools and materials, likely required a genuinely significant investment of focused time and practiced skill, the kind of specialized craft knowledge that would have been taught carefully and valued highly within a group that depended on a steady supply of well-made needles to keep its cold-weather clothing in usable repair. The oldest currently known eyed needles appear in the archaeological record at sites in southern Siberia, dating to roughly 40,000 years ago. Similar tools appear somewhat later at sites in the Caucasus region, dated to around 38,000 years ago, followed by East Asian examples dated to roughly 30,000 years ago, and European examples appearing by around 26,000 years ago. This is a striking geographic and chronological pattern. The earliest eyed needles do not appear in Africa, where the underlying clothing technology very likely originated according to the Lice evidence. They appear instead in some of the coldest, harshest environments human populations had expanded into by this point in prehistory, in northern Eurasia, during a period associated with the depths of the last major glacial cycle. This pattern makes practical sense once you consider what these environments actually demanded. A loosely wrapped hide, adequate for a cool African night, or even a moderately cold European autumn, would not have been sufficient protection for the extreme, sustained cold of an Ice Age winter in Siberia. Surviving in that kind of environment, for extended periods, through entire seasons of brutal sub-zero temperatures, required clothing sealed tightly enough to trap body heat effectively, without gaps or loose openings that wind and cold could exploit. The technological jump from all-punched, loosely joined hide clothing to needle-sewn, tightly fitted garments appears to track very closely with the movement of human populations into precisely the environments where that improved protection would have made the difference between survival and death. There is a further, somewhat unexpected layer to this story, one uncovered by researchers studying not just when eyed needles appeared, but why they became necessary at all, given that awls alone were already capable of producing functional stitched clothing. One archaeologist who examined this question closely proposed an explanation that connects clothing technology to an entirely different, seemingly unrelated aspect of prehistoric life: personal decoration and self-expression. Across many prehistoric cultures, researchers have found extensive evidence of people decorating their own bodies directly, using pigments, small pierced beads, and shells worn against bare or partially bare skin. As clothing became more essential for basic survival in extreme cold, fully covering the body for extended periods out of pure necessity, that same clothing may have also covered up the exposed skin people had previously used as a canvas for this kind of decoration and display. If a person's decorated skin was now hidden beneath thick, necessary winter clothing for much of the year, the desire for personal display and social signaling did not simply disappear. According to this theory, it shifted onto the clothing itself, driving demand for more elaborate, carefully sewn garments capable of holding decorative beads, shells, and ornamentation sewn directly onto the fabric or hide, a task that requires the precision only an eyed needle can provide. Whether or not this specific theory about decoration fully explains the timing of the eyed needle's invention, it points towards something worth remembering throughout this investigation. Clothing was very likely never only about pure biological survival, even at its most extreme. From a very early point, it may have also carried social meaning, marking identity, status, or belonging within a group, in addition to its basic function of keeping a hairless body alive through a cold night. That dual purpose, survival and identity, intertwined in a single object worn against the skin, is a thread that continues through clothing's entire subsequent history, all the way to the clothing choices people make every single day in the present. What the eyed needle evidence ultimately confirms, alongside the earlier bone awl evidence, is a clear technological progression stretched across tens of thousands of years, from simple draped hide coverings, likely originating in Africa well before any surviving tool evidence, to more carefully shaped and all-joined garments by around 80,000 years ago, to fully tailored, tightly sewn cold-weather clothing capable of supporting real decoration, appearing specifically in the coldest regions humans had expanded into by around 40,000 years ago and later. This progression does not contradict the lice evidence. It extends it, filling in the gap between an origin point the insects can only estimate broadly and a much more precise, tool-based record of how that early clothing technology was refined, improved, and adapted as human populations pushed further and further from the warm African environment their bodies had originally evolved for. There is one further piece of African evidence that fits directly into this window, and it comes not from a hide-working tool at all, but from a discovery that at first glance seems to belong to an entirely different part of the human story: the deliberate production and storage of pigment. At Blombo's Cave on the southern coast of South Africa, archaeologists excavating in the layers below the cave floor uncovered something unexpected in 2008. 2 abalone shells, found together, each containing the remains of a deliberately mixed, liquefied substance rich in ochre, a naturally occurring reddish or yellowish mineral pigment. Alongside the shells lay grindstones, hammerstones, fragments of bone and charcoal, forming what researchers described as 2 complete, spatially associated toolkits, each one representing every stage of a deliberate production process: grinding raw ochre into fine powder, combining it with other materials, mixing it into a liquid form, and then storing the finished product for later use inside a carefully chosen container. Dating using multiple independent methods placed this activity at approximately 100,000 years ago, squarely within the broad window the clothing lice evidence points toward. The significance of this find reaches well beyond the pigment itself. Producing and storing a compound like this requires a level of forward planning that researchers consider a genuine benchmark in the evolution of complex human behavior: sourcing the right raw materials, understanding how to combine them into a stable, usable mixture, and then deliberately setting some aside in a chosen container for use at a later point rather than immediately. This is not incidental, opportunistic behavior. It is planned, repeatable, and technical, evidence of people thinking ahead, preparing materials in advance of the moment they would actually be needed. What this has to do with clothing specifically is a question the researchers who made the discovery addressed directly. Ochre of this kind, ground into powder and mixed into a workable paste, has several plausible uses in a Middle Stone Age African context, as a pigment applied directly to skin for decoration or symbolic marking, as a substance offering some measure of protection against sun exposure on bare skin, and, significantly for this investigation, as a material that may have been applied to clothing itself, whether for decoration, for symbolic marking, or as part of the hide preparation process, since ochre and similar mineral compounds are known in later traditional tanning practices around the world to assist in preserving and treating animal hide. The researchers who published this find noted explicitly that ochre may have been applied with real intent as decoration, on bodies and quite possibly on clothing during exactly this period. This detail deserves to be placed directly alongside the clothing lice evidence, because both point toward the same broad conclusion from two entirely independent directions. The lice evidence suggests clothing existed by this general period, based on the biology and genetics of an insect dependent on it. The Blombos cave evidence, entirely unrelated in method and material, shows a population in Africa at almost precisely the same broad period, already engaged in sophisticated, planned, technical production of a substance closely associated in later human history with the treatment, decoration, and symbolic use of both skin and clothing. Neither piece of evidence proves the other, but taken together, they describe a population considerably more behaviorally complex, more capable of planning, teaching, and technical production than the simple image of early humans slowly, accidentally stumbling into clothing out of pure cold desperation would suggest. With this progression established, from hairless African ancestor to early draped hide covering, to a behaviorally sophisticated African population already engaged in planned pigment production around 100,000 years ago, to Neanderthal cold-weather technology developed independently in Europe, to fitted and finally sewn modern human clothing, the investigation now turns to a genuinely difficult scientific problem. How confident can researchers actually be in any of these specific dates? And what happens when different lines of evidence, the lice, the genetics, and the physical tools, do not perfectly agree with one another? Chapter 7. When the evidence disagrees. Good science rarely produces one tidy number that everyone accepts without argument, and the story of clothing lice is a clear example of that reality. The two major genetic studies at the center of this investigation, the earlier Leipzig research and the later Florida research, do not agree on a single precise date. One points toward a central estimate of roughly 72,000 years ago. The other, using a larger data set and updated statistical methods, suggests something considerably older, potentially reaching as far back as 170,000 years, with a lower bound of around 83,000 years. These are not small discrepancies. They represent a difference of tens of thousands of years, an enormous span of time by any ordinary measure, even if it is a comparatively narrow window within the overall scale of human evolutionary history. It would be easy to see this disagreement as a weakness, a sign that the entire method is unreliable and the whole investigation rests on shaky ground. A more accurate way to understand it is as a normal, expected feature of how molecular clock research actually works, particularly when applied to organisms like lice, which have been studied far less intensively than humans themselves. Every molecular clock estimate depends on a chain of underlying assumptions. How quickly a particular kind of mutation accumulates in a particular kind of organism, how large and genetically diverse the sampled population actually was, and how accurately researchers can calibrate their mutation rate using whatever independent evidence happens to be available. Small differences in any of these underlying assumptions can shift the final estimated date substantially, even when the basic genetic data itself is solid, and the researchers involved are working carefully and in good faith. The later Florida study explicitly addressed this issue, noting that its authors had access to a considerably larger genetic data set than the earlier Leipzig research, along with calculation methods specifically designed to reduce certain sources of statistical error present in the original approach. This does not necessarily mean the newer estimate is simply correct, while the older one was simply wrong. It means the newer estimate was built using improved tools and more data, which generally, though not always, produces a more reliable result. Science tends to work this way. An initial estimate opens a door, a rough first answer to a previously unanswerable question. Later research, building on that initial work with better data and refined methods, narrows the range and improves confidence, without necessarily discarding the earlier work entirely. The earlier study still deserves credit for being the first to demonstrate that this kind of evidence could be used at all. There is a useful way to think about what these two studies actually agree on, which turns out to be more scientifically important than the specific number they disagree about. Both studies place the origin of human clothing lice, and therefore the earliest plausible origin of clothing itself, somewhere within a broad window stretching from roughly 70,000 to 170,000 years ago. Both studies find that this population most likely originated in Africa, based on the same pattern of higher genetic diversity within African louse populations compared to those found elsewhere. And both studies agree on the underlying biological logic driving the whole method, that body lice cannot exist without clothing, and therefore cannot have evolved into a distinct population before clothing did. On these 3 points, the core logic of the method, the general time window, and the African point of origin, the two studies are in strong agreement, even while disagreeing on the precise central date within that window. This is where the second major line of evidence, the archaeological record of hide-working tools, becomes genuinely important, not as a competing answer, but as an independent check on the lice-based estimate. If the lice evidence were simply unreliable or arbitrary, there would be no particular reason to expect it to line up with anything found in the physical archaeological record. Instead, the two lines of evidence turn out to complement each other in a meaningful way. The oldest known bone awls, physical tools capable of producing genuinely fitted, joined clothing rather than simple draped coverings, date to roughly 80,000 years ago. That figure sits almost precisely inside the overlapping window suggested by both lice studies, closer to the lower end of the Florida estimate, and reasonably close to the upper range of the Leipzig estimate as well. Independent evidence, using a completely different method, a completely different kind of data, and researchers working in a completely different scientific discipline, converges on a broadly similar period. That kind of convergence between unrelated methods is one of the strongest forms of confirmation available in any historical science, stronger by far than either piece of evidence would be on its own. It's worth being equally honest about what this convergence does not prove. The bone awl evidence marks a moment when hide working had clearly advanced to the point of producing fitted, joined garments, not necessarily the very first moment any form of clothing at all came into use. Simple draped hide coverings, requiring nothing more than a basic hide scraper, could plausibly have existed considerably earlier than 80,000 years ago, leaving no distinguishable tool evidence behind at all, since a scraper used to prepare a hide for wearing looks identical to a scraper used to prepare a hide for any other purpose. This means the true origin of clothing in some very basic form could sit anywhere within, or even slightly before, the range the lice evidence suggests, with the 80,000-year-old awls marking a later refinement rather than the absolute beginning. There is a further complication worth addressing directly, because responsible science requires acknowledging it rather than smoothing it over. Some researchers have raised valid questions about how reliably a molecular clock calibrated using modern head lice and body lice populations can be projected backward across such an enormous span of time, particularly given how much human population movement, mixing, and change has occurred across the tens of thousands of years since the original divergence. Louse populations, like human populations, have been affected by migration, by periods of population decline and expansion, and by contact between different human groups carrying genetically distinct louse populations of their own. Untangling all of these later complications from the original, ancient divergence signal is a genuinely difficult statistical problem, and researchers working on this question continue to refine their methods as new genetic techniques and larger datasets become available. None of this means the lice evidence should be dismissed. It means the appropriate level of confidence is a range, not a single fixed date. and that range should be understood as our current best scientific estimate, subject to revision as methods improve, rather than a final, unchangeable answer carved in stone. This is, in fact, exactly how the researchers who conducted this work describe their own findings. They present central estimates alongside honest statements of uncertainty, and they frame their conclusions as a meaningful, evidence-based narrowing of a previously wide-open question, not as a definitive final word closing the investigation completely. There is also a related question worth addressing here, because it connects the lice evidence directly back to a species discussed earlier in this investigation, Neanderthals. If Neanderthal populations were working hides and producing string by roughly 40 to 50,000 years ago, and quite possibly earlier, does that timeline fit comfortably alongside the modern human lice evidence, or does it create some kind of contradiction? The honest answer is that it does not create a contradiction, but it does require careful, separate thinking about two different populations. Human body lice, the specific insect studied in the genetic research at the center of this investigation, evolved specifically as a parasite of modern humans, tracking modern human genetic history and modern human population movement. Neanderthals, as a separate hominin lineage with their own distinct evolutionary history, would not necessarily have shared the exact same parasite lineage or the same clothing adoption timeline, even if they were independently developing broadly similar hide-working solutions to broadly similar cold-weather survival problems around a roughly overlapping period. In other words, the lice evidence tells us specifically about our own species' relationship with clothing. It does not, and cannot, tell us anything directly about when Neanderthals began working hides, since Neanderthals are not the population whose lice were studied in this research. The two lines of evidence, the modern human lice data and the separate archaeological evidence for Neanderthal hide-working, are telling two related but genuinely distinct stories. Two different hominin populations, quite possibly, arriving independently at broadly similar solutions to the same fundamental problem of surviving in a body that had lost its natural insulating coat, using whatever combination of materials, skills, and cultural knowledge each population happened to have available to them. There is one more source of complication worth addressing directly, because a careful investigation does not get to simply ignore an inconvenient piece of evidence just because it complicates an otherwise tidy narrative. Some archaeological findings suggest that certain populations were processing hides using blade tools considerably earlier than the lice evidence's lower bound would suggest, with some evidence for blade technology in the Caucasus region stretching back as far as 300,000 years, produced by populations that existed long before anatomically modern humans evolved at all. Does this contradict the lice-based timeline for clothing's origin among modern humans specifically? The answer, on careful examination, is no, but understanding why requires being precise about exactly what different pieces of evidence are actually measuring. Blade tools capable of cutting and shaping hide do not by themselves tell us the hide was being turned into clothing rather than being used for one of the many other practical purposes animal skins can serve, carrying material, covering a sleeping area, or serving as a working surface for other tasks. The bone-awl evidence discussed earlier is considerably more specific, because a tool designed to punch a controlled series of holes through prepared hide strongly implies an intention to join separate pieces together into a shaped object, a criterion much closer to what would reasonably be called clothing. And the lice evidence is more specific still, since it does not depend on interpreting the likely function of a stone tool at all, but instead on the hard biological requirement of an insect that can only exist inside worn, sustained clothing. These different forms of evidence are answering related but genuinely distinct questions. How far back does hide processing in general extend? How far back does evidence for shaped, joined hide garments specifically extend? And how far back does evidence for clothing worn consistently enough to sustain a dependent insect population extend? Recognizing that these are different questions, rather than competing answers to the same question, resolves what might otherwise look like a contradiction between an older blade tool date and a younger lice-based estimate. This distinction matters for how the entire investigation should be understood. It is entirely possible, and quite likely, that people were cutting, shaping, and using animal hides for a wide variety of practical purposes for a very long stretch of time before anything resembling regularly worn, body-fitted clothing existed in the specific sense this documentary has been investigating. The lice evidence is not claiming to date the first moment any hominin population anywhere ever touched an animal hide with a cutting tool. It is dating something considerably more specific, the point at which clothing, worn consistently enough and closely enough against the body to create a viable, sustained habitat for a specialized parasite, first became a regular part of human life. That is a meaningfully different, and in some ways more precisely defined, question than simply asking when hide working of any kind began. And it is the reason the lice evidence and the older blade tool evidence can both be entirely accurate without actually contradicting one another. Taken as a whole, this chapter's honest accounting of disagreement, uncertainty, and complication does not weaken the overall picture this investigation has been building. If anything, it strengthens it by demonstrating that the researchers involved are engaging carefully and critically with their own evidence, rather than overstating their confidence. Multiple independent lines of evidence, the lice genetics, the bone awl dates, the African origin signature, and the later needle and migration evidence still to come, continue to point in a broadly consistent direction, even while leaving specific details appropriately uncertain. That consistency, hard-won and honestly qualified, is exactly the kind of evidence a responsible investigation should trust. Chapter 8. What it cost to stay warm. Understanding when clothing began is only part of this story. Understanding what that invention actually meant for the people living through it, day after day, season after season, is where the evidence stops being simply a set of dates and starts being a story about real human lives. Consider what it would have actually taken, in practical terms, to produce a single usable piece of hide clothing using the technology available to early human populations. It began with a successful hunt, itself no small achievement, requiring skill, cooperation, and no small amount of danger in bringing down a large animal using stone-tipped weapons at close range. Once an animal was killed, the hide had to be removed carefully, without excessive damage, using a stone blade requiring real precision and practiced skill. That raw hide, freshly removed, is not yet remotely usable as clothing. It is heavy, stiff, prone to rotting within days if left untreated, and covered in flesh, fat, and connective tissue that has to be scraped away completely before any further work can begin. This is where the hide scrapers discussed earlier come into direct physical use. Removing the remaining flesh and fat from the underside of a hide using a handheld stone scraper is slow, repetitive, physically demanding work, requiring sustained attention over what was very likely hours of continuous effort for even a single hide. Once scraped clean, the hide still had to be treated further to prevent it from becoming stiff and unworkable as it dried, a process that likely involved some combination of physical working, stretching, and possibly the application of natural substances such as animal fats or brains, a preservation method documented in many later traditional hide-working cultures around the world and considered a strong candidate for very early practice as well, even though direct prehistoric evidence for the specific substances used this far back remains limited. Only after this lengthy preparation process was a hide ready to be shaped and joined into something resembling a garment. Using a bone awl, a worker had to punch a controlled series of holes along the edges of the shaped pieces, holes that had to be spaced closely and consistently enough to allow for a reasonably tight, wind-resistant seam, without being placed so closely together that the hide itself became weakened and prone to tearing along the stitched line. Sinew, likely taken from the same animal the hide came from, or plant fiber cordage requiring its own separate preparation process, then had to be threaded through these punched holes and pulled tight, seam by seam, until the individual pieces of hide were joined into a single, wearable garment. This entire process, from a successful hunt through to a finished piece of clothing, represents an enormous investment of time, skill, and coordinated effort. It was very likely not the work of a single person acting alone from start to finish, but a set of tasks distributed across multiple people within a group, each contributing particular skills, knowledge, and labor built up and refined over years of practice and teaching. A finished garment, understood this way, was not a disposable, easily replaced object. It represented a substantial investment of collective effort, and it would very likely have been treated accordingly, repaired rather than discarded when damaged, passed down or reused rather than casually replaced, and very possibly carrying real social and practical value beyond its basic function of providing warmth. This changes how we should picture early clothing in daily life. It was very unlikely to have been abundant, in the sense of individuals owning multiple garments the way most people in wealthy modern societies do today. A single well-made hide garment, carefully maintained and repaired over an extended period, was very possibly a person's primary or even only significant piece of clothing for years at a time, an object of real, ongoing practical importance to survival, requiring continued care and attention rather than being taken for granted. Consider too what the absence of adequate clothing would have meant in a genuinely cold environment for the people who had not yet developed, obtained, or successfully maintained sufficient protection. Human survival in extreme cold without adequate insulation is measured not in days but in hours. The body's core temperature, if allowed to drop significantly below normal, produces a rapid, dangerous cascade of physical effects: impaired coordination, confused thinking, dangerously reduced ability to perform even basic survival tasks, and eventually, if the exposure continues without intervention, death. For a species whose bodies had lost the natural fur coat that once provided automatic protection against exactly this danger, clothing was not a comfort or a convenience once populations moved into cold environments. It was the single technology standing between survival and death during a large part of the year, for a significant portion of the human population that had expanded beyond Africa's warmer regions. This reality would have shaped daily life, family structure, and social priorities in ways that are easy to overlook from a modern perspective, where clothing is cheap, mass-produced, and universally available. Producing and maintaining adequate clothing for an entire family group, including children, whose smaller bodies lose heat even more rapidly than adult bodies do, and elderly or injured group members who may have had reduced ability to move around and generate their own body heat through physical activity, would very likely have represented a significant, ongoing portion of a group's overall labor and planning, particularly heading into colder seasons. It is worth addressing directly who most likely carried out this demanding, physically taxing work, because the evidence here tells a clearer, and in some ways more interesting, story than popular assumption might suggest. For a long time, a common, largely unexamined picture of prehistoric daily life divided labor sharply along a single line: men hunting, women gathering and processing what men brought home, with hide working generally imagined as one of many domestic tasks assigned exclusively to women. The physical evidence, examined carefully, does not support such a rigid division. Skeletal remains from Neanderthal populations, studied for the specific kinds of bone trauma and physical wear that accumulate over a working lifetime, show strikingly similar patterns across male and female skeletons, the kind of shared, repeated physical stress consistent with both sexes participating directly in demanding, physically dangerous activity, including the pursuit of large game. More specifically relevant to this investigation, researchers studying dental wear, the distinctive pattern of grooves and chipping that forms on front teeth when they are used repeatedly as a kind of third hand to grip and pull material during a task such as softening or working hide, have found this same wear pattern distributed roughly equally across male and female individuals. This is exactly the kind of physical evidence that would be expected if hide working, including the demanding, repetitive labor of turning a raw skin into finished clothing, was shared broadly across a group, rather than assigned rigidly to one sex alone. This makes practical sense once you consider the basic realities of small group survival in a genuinely difficult environment. A band of early humans or Neanderthals living through a harsh glacial winter did not have the luxury of assigning survival-critical tasks based on rigid categories. Producing enough finished clothing to protect an entire group through a cold season was very likely too large and too urgent a task to leave to only half the available adults. Everyone capable of contributing skilled labor toward that goal very likely did so, whatever their sex, because the alternative, a group without enough clothing to survive the coldest months, threatened everyone equally. The evidence does not describe rigid, gendered roles handed down from some unchanging natural order. It describes a flexible, cooperative division of essential labor, shaped above all by what the group actually needed to survive. There is a specific detail here worth pausing on, because it connects directly to something many people watching this documentary will recognize from their own family history, even without realizing the connection stretches back this far. The skill of working hide, preparing material, and producing durable, repairable clothing was very likely something taught carefully across generations, passed from experienced hands to younger, less practiced ones, refined slowly over a lifetime of practice, rather than learned quickly or casually. A person skilled at this work would have held real, practical value within their group, their knowledge directly connected to whether the people around them survived a difficult winter or did not. If your own family has any memory, even a distant one, of a grandmother, grandfather, or other relative known for skill with sewing, mending, leatherwork, or making things last through careful repair rather than replacement, that specific pattern, valuing durable, well-maintained, carefully repaired clothing over casual, disposable replacement, is not simply an old-fashioned personal habit. It is, in a very real and direct sense, an echo of a survival pattern that shaped human daily life for tens of thousands of years before anyone alive today was born, a pattern so deeply embedded in how humans have historically related to clothing that it persisted as ordinary, unremarkable practical wisdom within living family memory, long after most people had lost any conscious awareness of just how old that wisdom actually was. This is also a moment worth pausing to invite a brief reflection of your own. If a memory like that exists somewhere in your family, a piece of practical clothing-related knowledge passed down, a story about a garment kept and repaired for years rather than replaced, it connects you, in a small but genuine way, to a pattern of human behavior stretching back tens of thousands of years, long before recorded history began. It is worth sitting with that thought for a moment before we continue. There is a further dimension to this daily reality worth including here, one centered specifically on the youngest and oldest members of any group relying on this technology. Children present a particular challenge for cold weather survival that adults do not face in quite the same way. A smaller body has a larger surface area relative to its overall volume than a larger body does, meaning heat escapes proportionally faster from a small child's body than from an adult's, even when both are wearing comparably effective clothing. This basic physical reality means clothing for children, whatever exact form it took, needed proportionally more attention relative to a child's size, and needed replacing considerably more often as a growing child's body changed shape and outgrew whatever had been made for them previously. A single well-made adult garment could realistically be expected to last for years, carefully repaired and maintained. A child's clothing, by contrast, likely required a far more continuous, ongoing cycle of production, resizing and remaking, an additional, largely invisible layer of labor that a group's skilled hide workers would have needed to sustain continuously, year after year, simply to keep pace with each child's normal growth. Elderly group members faced a related but distinct version of the same underlying problem. Aging bodies generally become less efficient at generating and retaining internal body heat. A combination of reduced muscle mass, changes in circulation, and, in some cases, reduced overall mobility, limiting the physical activity that helps a body stay warm through its own movement. An older group member, quite possibly including individuals whose accumulated knowledge and experience made them among the most valuable teachers and decision-makers within the group, may have depended on especially well-made, especially well-maintained clothing simply to remain safely mobile and functional through a cold season, clothing that younger, more physically active members of the group might have been able to manage without quite as urgently. This suggests that the careful production and maintenance of clothing was never solely about pure physical survival in the most minimal sense. It was also, in a very real way, about actively supporting the specific people within a group, the very young and the very old, who depended most heavily on that support to remain safe, capable, and included in the ongoing life of the group, rather than being left dangerously vulnerable by a body that could no longer entirely protect itself. The cost of clothing, in early human life, was never simply the physical labor of making it. It was also, in a very real sense, the accumulated knowledge required to make it well. Knowledge that had to be actively taught, actively practiced, and actively preserved within a group, generation after generation, in order for that group's clothing technology to remain reliable enough to keep surviving the next winter, and the winter after that, and the one after that. Chapter 9. The Place. Even Neanderthals could not reach understanding the true stakes of clothing technology requires understanding just how extreme some of the environments early humans eventually pushed into actually were. And there is no better way to grasp that than through the experience of a researcher who went looking for the origins of clothing and very nearly learned the lesson his own body's oldest way. An archaeologist trained in medicine, with a long-standing interest in exactly the question this documentary has been investigating, once travelled from a mild, sunny climate in the southern hemisphere to join an excavation in the Siberian mountains of eastern Russia. On his first morning at the site, despite sleeping in a well-padded modern sleeping bag, designed using centuries of accumulated cold weather clothing knowledge, he woke shivering, cold to his core. He moved close enough to the campfire that his gloves began to smoulder from the heat, and still the shivering did not stop. As someone trained in medicine, he recognized what was happening to his own body, the early symptoms of mild hypothermia, brought on despite modern equipment, in a region that, as he put it afterward, surely always demanded warm clothing from the people who lived there. That single uncomfortable morning captures something crucial about the environment this investigation eventually leads into. Siberia is not simply cold in the way a chilly autumn evening is cold. It represents one of the most consistently extreme, sustained cold environments on the entire planet, particularly during the depths of the last glacial period, when average temperatures across large stretches of the region would have made survival, without genuinely effective clothing, essentially impossible for more than a few hours at a time. This is precisely the environment where the archaeological record shows some of the earliest known eyed needles, alongside other sophisticated bone tools, appearing roughly 40,000 years ago, at cave sites including one known as Denisova Cave, a location whose name comes from a now well-known population of ancient humans first identified through genetic material recovered there. There is something worth pausing on in that single anecdote before moving to the wider archaeological picture. The researcher in question was not a casual visitor unfamiliar with cold weather. He was a trained medical doctor, specifically interested in the thermal limits of the human body, arriving with modern, purpose-built cold weather equipment developed using centuries of accumulated textile engineering. And still, on his very first morning, his own body began sliding toward a genuinely dangerous state purely from ordinary Siberian cold. This is worth remembering every time this documentary discusses ancient people surviving in this same region, using nothing but hand-scraped, hand-sewn animal hide. It was never a small or trivial achievement. It required clothing sophisticated enough and warm enough to outperform, in some meaningful sense, a modern nylon sleeping bag against one of the most demanding cold environments on the planet. And it required that level of performance not for one uncomfortable night at an excavation site, but for entire sustained seasons of ordinary daily life, year after year, generation after generation. Denisova Cave occupies an unusual and important place in the story of human prehistory more broadly. Genetic analysis of remains recovered from its layers revealed something remarkable. The cave was, at various points, home not just to modern humans, but also to Neanderthals, and to an entirely separate, previously unknown population of ancient humans, now called Denisovans, closely related to Neanderthals but genetically distinct from them. Researchers even recovered genetic evidence of a single individual who was directly the child of a Neanderthal parent and a Denisovan parent, definitive proof that these different human populations were not just living in roughly the same region, but were, at least occasionally, meeting, interacting, and interbreeding directly. This makes Denisova Cave an extraordinary natural laboratory for comparing how different human populations coped with the same extreme environment, a single site where the archaeological layers preserve, in sequence, the presence of three genetically distinct human populations, all facing the identical challenge of surviving in one of the coldest inhabited regions on Earth, using whatever combination of biology, behavior, and technology each population had available to it. All three of these populations, Neanderthals, Denisovans, and eventually modern humans, appear to have occupied this general region of southern Siberia at various points, separated in some cases by long stretches of time, and in other cases apparently overlapping directly. Evidence recovered from the site includes animal hide remains alongside signs of established fire use and shelter construction, pointing toward the kind of combined cold weather survival strategy, fire, shelter, and hide-based clothing working together, that would have been necessary for any of these populations to survive there for any extended length of time. But there is a genuinely important distinction that emerges once researchers trace the fuller pattern of exactly how far into the coldest parts of Eurasia each population managed to push. Neanderthals, despite clearly possessing hide-working technology, string-making ability, and likely some form of clothing, appear to have never ventured into the very harshest, most extreme northeastern reaches of Siberia. even during periods when the broader region was accessible. Modern humans arriving later and equipped specifically with the more advanced eyed needle sewing technology, capable of producing tightly fitted, well-sealed cold-weather garments, were able to push further into this extreme frontier than Neanderthals ever had, penetrating deep into the coldest habitable corners of northeastern Eurasia during periods that included the harshest phases of the last glacial cycle. This is a genuinely striking piece of evidence, because it suggests something more specific than simply modern humans had clothing. It suggests that a particular refinement in clothing technology, the shift from all-punched, loosely joined garments to tightly sewn, eyed needle-stitched clothing capable of fully sealing out wind and cold, may have functioned as something close to a hard technological boundary, a genuine limit on how far into extreme cold any human population, no matter how capable in other respects, could successfully push without it. Neanderthals, resourceful and clearly capable of surviving harsh conditions across huge stretches of Ice Age Europe for hundreds of thousands of years, still appear to have run into a real limit in the very coldest environments, a limit that modern humans, once equipped with more advanced sewing technology, were eventually able to cross. It is worth pausing to consider exactly why a loosely wrapped hide, adequate for much of Ice Age Europe, would fail so completely in the specific conditions of deep Siberian winter. A draped or poncho-style hide covering, however thick, still allows a continuous layer of cold outside air to make direct contact with warmer air trapped near the skin, wherever the wrap gaps, shifts, or fails to seal completely around the arms, neck, and legs during movement. In a moderately cold European environment, this kind of heat loss, while real, remained within a survivable range, particularly alongside fire, shelter, and the kind of loose hide covering Neanderthal populations appear to have relied on. In the more extreme cold of glacial period Siberia, air temperatures could remain far below freezing for sustained stretches, sometimes for months at a time, with wind chill compounding the danger significantly. Under those specific conditions, even a small continuous gap in a garment's seal becomes a serious, potentially fatal source of heat loss, particularly for extremities such as fingers, toes, and the face, where frostbite can begin within a very short window of exposure. A tightly sewn, eyed needle-stitched garment, fitted closely to the body's actual shape and sealed at the seams, dramatically reduces this kind of gap-driven heat loss in a way a loosely wrapped hide simply cannot match, regardless of how thick or well-prepared that hide might otherwise be. Placing this alongside the broader archaeological pattern discussed earlier makes the overall picture considerably clearer. Blade tools appear in the Caucasus region as far back as roughly 300,000 years ago, and blade tools alongside awls appear in southern Africa during a documented very cold climate phase roughly 75,000 years ago, suggesting hide-working technology was already responding directly to cold pressure at that point, well within the broad window suggested by the clothing lice evidence. Northern China shows blade tools by around 40,000 years ago, bone awls by around 35,000 years ago, and eyed needles by around 30,000 years ago, a clear, traceable technological sequence unfolding over time in that specific region. In Europe, eyed needles appear to have accompanied modern human populations, specifically during their push toward the very coldest phase of the last glacial cycle, the period known as the last glacial maximum, roughly 22,000 years ago, precisely when the need for the most effective possible cold weather protection would have been at its absolute peak. Taken together, this regional pattern tells a story of ongoing refinement, not a single invention. Clothing did not appear once, in one place, in one final form, and then remain unchanged for the rest of human history. It appears to have developed first, in some early, likely simpler form, in Africa, based on the lice evidence, then been carried outward by migrating populations, then independently refined, adapted, and improved again and again as those populations encountered new, increasingly demanding environments, from the relatively moderate cold of early Ice Age Europe to the genuinely extreme, life-threatening cold of glacial period Siberia and the far northeastern reaches of Eurasia. Each new environment appears to have pushed clothing technology a step further, and the archaeological record, read carefully across multiple regions, preserves a rough outline of exactly how and where those steps happened. There is a broader, almost philosophical point worth drawing out of this pattern before moving forward. The story of clothing origin is not really a story about a single clever idea, discovered once and then simply used forever afterward without change. It is a story about a technology under constant pressure to improve, refined again and again by different populations, in different regions, over an enormous span of time, each refinement unlocking access to environments that would otherwise have remained permanently off-limits to a hairless, heat-adapted body. The insect that first suggested a rough starting date for this whole process, evolving quietly in the fabric of the earliest garments, could not have known it would eventually help modern researchers trace not just when clothing began, but how directly its ongoing improvement shaped the entire geographic story of where human beings, and only human beings among all the hominin populations that once existed alongside us, ultimately managed to live. There is one final layer of nuance worth adding here, because it keeps this investigation honest about the limits of what any single line of evidence, including the molecular clock method at the center of this whole story, can actually tell us. Estimating a mutation rate accurately enough to calibrate a genetic clock requires some kind of independent reference point, a way of checking the assumed rate of change against something researchers can date through an entirely separate method. For the human body louse studies, researchers calibrated their mutation rate estimates in part by comparing the genetic divergence patterns of lice against the separately documented, independently dated split between different human populations and against known patterns of primate louse evolution more broadly, an approach that carries its own reasonable but real margin of built-in uncertainty. This is precisely why responsible researchers report their findings as a range rather than a single fixed year, and precisely why this documentary has treated that stated range, rather than any single headline number, as the most honest answer this evidence can currently support. A margin of error is not a flaw hidden inside the science. It is the science being transparent about exactly how much confidence its own methods can currently justify, an honesty that should, if anything, increase rather than decrease trust in the overall picture the evidence presents. A viewer who has followed this investigation closely should walk away trusting the broad window this evidence describes, precisely because that window has been presented honestly, with its genuine uncertainty intact, rather than rounded off into a single falsely precise number for the sake of a cleaner story. It is also worth acknowledging plainly that this documentary has, by necessity, focused its most detailed attention on the regions where the strongest, most extensively studied evidence happens to exist: Africa, Western Europe, and southern Siberia. This is a reflection of where archaeological research has historically concentrated its resources and attention, not necessarily a claim that clothing technology developed only in these specific places, or that other regions and populations played no meaningful part in this broader story. Researchers working in East Asia, in the Americas, and elsewhere continue to uncover additional evidence that will very likely refine, and in some cases meaningfully revise, parts of the picture this investigation has presented. A responsible account of deep prehistory remains open to that kind of revision as a matter of principle, built from the best currently available evidence, rather than treated as a final, unchangeable verdict. Given all of this, it becomes possible to sketch a fuller, more complete outline of the environments this technology eventually made accessible. Beyond the Siberian interior and Denisova cave itself, sewn, fitted clothing appears to have been a necessary precondition for the eventual human movement across the far northeastern edge of Eurasia and, eventually, across the land connection that periodically existed between what is now the far eastern edge of Russia and the westernmost edge of North America during periods of lowered sea level associated with glacial cycles. Populations moving into this region, and eventually onward into the Americas, were pushing into some of the coldest, most physically demanding environments our species has ever successfully inhabited. Environments that, based on everything the archaeological and genetic evidence together suggest, would have remained permanently unreachable without the specific combination of fitted, tightly sewn cold-weather clothing this investigation has traced from its earliest African origins, through its final, most sophisticated Siberian refinement. Chapter 10. The Thread That Still Connects Us. By this point in the investigation, the outline of an answer has taken clear shape, built from multiple independent lines of evidence that, despite their very different sources, keep pointing toward a broadly consistent story. It is worth drawing that full picture together now, before turning to what it actually means for the people living through it, and for anyone listening to this story today. The story begins more than 1 million years ago, when early ancestors of modern humans lost most of their body hair, very likely as an adaptation allowing more efficient heat loss through sweating during increasingly active, sun-exposed daily life on the open landscapes of Africa. This left the human body permanently more exposed to sun, to cold, and to the elements generally, a vulnerability offset, at least within Africa's warmer regions, by the evolution of protective dark skin pigmentation. For an enormous stretch of time afterward, human ancestors lived successfully within this arrangement, hairless, dark-skinned, heat-adapted, and confined largely to environments where that combination of traits worked as an advantage rather than a threat. Then, at some point within a broad window that current genetic evidence places somewhere between roughly 70,000 and 170,000 years ago, something changed. Human body lice, an insect entirely dependent on clothing for its survival, began evolving as a genetically distinct population, splitting away from the ancestral head louse lineage. Because this insect cannot exist without clothing, its evolutionary origin marks, as closely as currently available science allows us to determine, the approximate period when clothing itself first came into meaningful, sustained use among early modern human populations, very likely in Africa, based on the same African origin genetic signature seen throughout broader human population history. This early clothing, based on the archaeological evidence available, was very likely simple, loosely wrapped or draped animal hide, prepared using basic stone scraping tools that leave no way to distinguish, on their own, whether the resulting hide was worn, used as bedding, or put to some other practical use. By roughly 80,000 years ago, the archaeological record shows something more specific. Bone awls capable of punching controlled holes through prepared hide, suggesting a meaningful shift toward more deliberately shaped, joined garments, closer to genuine tailored clothing than simple draping. As human populations began moving out of Africa in more substantial, sustained waves, particularly from around 100,000 years ago onward, they carried this existing clothing technology with them into progressively colder, more challenging environments. Separately, and apparently independently, Neanderthal populations already established across Ice Age Europe developed their own hide-working technology, including specialized rib bone tools for softening hide and direct evidence of manufactured cordage, allowing them to survive successfully across hundreds of thousands of years in a range of difficult, often genuinely cold environments, very likely using simple wrapped or poncho-style hide coverings rather than closely fitted, tailored garments. The final major refinement in this long technological story appears in the archaeological record roughly 40,000 years ago and afterward, concentrated specifically in some of the coldest regions modern humans had expanded into. The eyed needle, a tool requiring genuine specialized skill to produce, allowing for tightly sewn, closely fitted garments capable of sealing out wind and extreme cold far more effectively than anything possible with a simple awl-punched seam. This technology appears to have functioned as something close to a genuine threshold, one that Neanderthal populations, despite their own considerable hide-working sophistication, never fully crossed, and one that allowed modern humans to eventually push successfully into the most extreme cold environments across northeastern Eurasia, environments that remained permanently beyond Neanderthal reach. This is, as honestly and completely as current evidence allows it to be told, the answer to the question this documentary set out to investigate. It is not a single date. It is a broad window of origin, roughly 70,000 to 170,000 years ago, most likely centered somewhere within that range depending on which specific genetic studies methods are weighted most heavily, followed by a long, traceable process of ongoing technological refinement, stretching across tens of thousands of years afterward, each step pushing the boundary of where a hairless, heat-adapted human body could successfully survive a little further outward. It is worth taking a moment to place this window against a small handful of other, more familiar dates from human history, if only to help hold its true scale in mind. The entire span of written human history, from the earliest known writing systems through to the present day, covers perhaps 5,000 years. The Blombos Cave Ochre Workshop, itself already an extraordinarily old piece of evidence for planned, deliberate human behavior, sits at roughly 100,000 years ago, 20 times deeper into the past than the entire history of writing. The clothing lice evidence, at its oldest estimated boundary of 170,000 years, reaches back further still, deep enough that the specific population of early modern humans involved would have looked at the world, and very likely thought about it, in ways not entirely unfamiliar to us today, and yet lived through a stretch of time before almost every other technology, symbol, or social structure that later defined human civilization as it is now understood had come into existence at all. Clothing sits among the genuinely oldest deliberate technologies human beings have ever produced, older by a wide margin than agriculture, than permanent settlement, than writing, than almost anything most people would instinctively picture when asked to imagine the deep human past. What makes this story genuinely remarkable is not simply the timeline itself, but what the timeline reveals about the kind of species that produced it. Clothing was not invented once, by necessity, in a single desperate moment. The evidence suggests it was developed first under relatively mild pressure, likely refined gradually over a long period before it became a matter of true survival necessity, and only afterward carried outward and pushed to increasingly sophisticated extremes as successive human populations encountered increasingly demanding environments. This is a pattern of careful, patient, generational problem-solving, knowledge accumulated, taught, and improved across an enormous span of time, rather than a single flash of inventive genius solving an immediate crisis. It is also, in its own way, a deeply intimate story, one that connects directly to something almost everyone watching this documentary does every single morning without a second thought. The simple act of getting dressed, chosen so automatically today that it barely registers as a decision at all, sits at the end of an unbroken chain of practical knowledge stretching back, at minimum, tens of thousands of years, refined by countless individuals across countless generations, most of them leaving no other trace in the historical record beyond this one quiet, essential piece of accumulated skill: how to take the hide or fiber the world provides and turn it into something that keeps a fragile, hairless human body alive through conditions its own biology alone was never built to withstand. The insect that helped reveal this story, the small, specialized parasite still living quietly in clothing across the world today, carries no awareness of any of this. It simply continues doing what it has always done, existing entirely because human beings, a very long time ago, first solved a problem their own bodies could not solve alone. In an unexpected way, that insect represents one of the oldest, most literal pieces of physical evidence connecting every person alive today back to a decision, or more accurately, a slow, gradual, repeated series of decisions, made by ancestors none of us will ever know by name, at some point during a window of prehistory tens of thousands of years deep, when someone, faced with a body that had already given up its natural coat 1,000,000 years before, first reached for an animal hide and began the long process of turning it into something worn. There is a quiet symmetry worth noting before this investigation closes. The very quality that makes the body louse such an unwelcome, unwanted presence in human life today, its total, specialized dependence on the intimate space between skin and fabric, is the exact same quality that turned it into one of the most valuable, unexpected witnesses available to modern science for understanding a piece of our own deep history that would otherwise have remained permanently unknowable. Nobody studying lice a century ago set out looking for the origin of clothing. Researchers studying these insects for entirely different reasons, curious about broader patterns of parasite evolution and host relationships, gradually realized that the insect's own evolutionary story was, quite literally, chained to a question about human history that direct archaeological evidence could never fully answer on its own. It is a reminder that meaningful evidence about the deep human past does not always come from the places researchers expect to find it, and that the smallest, least glamorous fragments of the natural world sometimes carry the clearest record of decisions our ancestors made a very long time ago. Decisions that, in this particular case, quietly made it possible for the human species to eventually live almost anywhere on the surface of the planet. Conclusion. There is something genuinely unusual about the shape of this particular investigation, compared to most historical mysteries. Most detective work in archaeology follows physical evidence directly to a conclusion. A bone reveals an age. A tool reveals a technique. A burial reveals a belief. This investigation had to work around a fundamental absence. The object at the center of the entire question, the clothing itself, was never going to survive long enough to be examined directly. Cloth rots. Hide decays. 100,000 years erases almost everything organic a person could have worn. And yet the answer still came, not despite that absence, but because researchers were willing to look somewhere nobody expected, into the genetics of a small, unglamorous parasite that most people spend their lives trying to avoid entirely. The human body louse, trapped by its own evolution into an existence completely dependent on clothing, carried inside its DNA a rough, honest record of roughly how long that dependency has existed. It could not lie about its own history, because its entire biology was shaped by the very technology this investigation set out to date. What emerged from that unlikely source, once combined with genetic evidence for the earlier loss of human body hair, with physical evidence of hide scraping and hide softening tools stretching back deep into the Pleistocene, with the planned, technical ochre production documented at Blombos Cave roughly 100,000 years ago, with Neanderthal string-making and rib-bone leatherworking tools, with bone awls appearing roughly 80,000 years ago, and with eyed needles appearing specifically in the coldest regions humans eventually settled, roughly 40,000 years ago and afterward, is a picture with real coherence. Not a single perfect date, but a consistent, mutually reinforcing window of time, and a clear, traceable pattern of ongoing refinement afterward, each new piece of evidence independently supporting a broadly similar story. None of these individual pieces of evidence, taken entirely alone, would be enough to answer the question this documentary set out to investigate with real confidence. A single genetic study of one insect species could reasonably be questioned on its own. A handful of hide-scraping tools, on their own, could not distinguish clothing from bedding or shelter material. A single find of ancient pigment, however striking, could not by itself prove anything definite about clothing specifically. It is the accumulation, the way each independent line of evidence, developed by entirely different researchers, using entirely different methods, in entirely different scientific disciplines, keeps arriving at a broadly overlapping answer that gives this investigation's conclusion real weight. This is how difficult questions about the deep human past are actually answered, not through one single decisive discovery, but through the slow, patient accumulation of independent, mutually reinforcing evidence, each piece filling in part of a picture no single piece could ever complete alone. The central finding stands on solid, if appropriately uncertain ground. Human clothing very likely first emerged somewhere between roughly 70,000 and 170,000 years ago, most probably in Africa, among the ancestors of every person alive today. Developed initially under conditions that did not yet demand it for basic survival, and only later carried outward, refined, and pushed to increasingly sophisticated extremes as human populations expanded into environments a bare, hairless body could never have survived unprotected. This was never simply a story about staying warm. It was the story of how one particular kind of ape, having already given up the natural coat evolution once provided, found a way to build a replacement out of raw material taken from the world around it, refined that replacement patiently across tens of thousands of years and countless generations, and in doing so, unlocked nearly the entire habitable surface of the planet, territory that would otherwise have remained permanently off-limits to a species built for the warmth of an African savanna and nothing colder. The next time you get dressed, pulling on a simple layer of fabric without a second thought before walking out into whatever the day's weather happens to bring, there is a real, direct, traceable line connecting that small, automatic action back to a specific, identifiable moment in deep prehistory. Back to a body that had already spent the better part of 1,000,000 years without any covering at all. Back to a hide, carefully scraped, softened, and eventually pierced and joined by hands belonging to someone whose name will never be known, working with knowledge passed down from someone else before them, and passed onward, in turn, to someone else after. And, quietly, persistently, back to a small insect, still alive today, in exactly the environment that first gave it a home, still carrying, in its own limited, unknowing way, a genetic record of the precise moment human beings first decided that a bare, exposed body was a problem worth solving. That solution is still with us today, worn without a second thought every single day, connecting anyone alive right now to ancestors who lived, worked, taught, and survived an almost unimaginable span of time before any of it was ever written down. The next time cold air meets the back of your neck as you step outside, and you reach without thinking for another layer, You are repeating an action whose deepest roots reach back further than almost any other habit in human life. Older than any language now spoken, older than any city ever built, carried forward unbroken by countless hands whose names are gone, but whose solution to the cold remains, quietly, on every one of us, every single day.